This uniform electric field here, the blue lines, it's generated by the separation of charge. The field lines originate on the positive charge, and there's an infinite amount of these on this infinite plane, and they terminate on the negative charge. The difference in electric potential or voltage between the two plates is responsible for the electric field. Energy is being put into the parallel plane and charge system here when a positive charge moves in the opposite direction of the electric field. So let's circle what's going on here. Here's a positive charge, and it's moving upwards. The electric field is trying to push it downwards, so the only way it can go up is if you add an external force that pushes it up. Similarly, if you have a negative charge, and that moves in the same direction of the electric field, if that were to go like that, you would have to put in positive energy to move it down because the electric field is trying to push it up. So in both cases, positive work is being done by the external force, and since the positive charge is moving opposite the electric field, negative work is being done by the field. Here's an illustration of what would happen if we just put the positive charge in the field here and did not put any force on it. In this case, the work done by the electric field is positive. The field is in the same direction as the charge's motion, so by the definition we've used for potential energy, that it's the negative of the work done by the field, the potential energy of this system will decrease. That's directly analogous to the movement of a mass within a gravitational field. If this was the gravitational field, these blue lines, and we put a mass here, it would fall down. The potential energy would decrease. If there is no other force present, the charge will accelerate to the bottom by Newton's second law, F equals ma. But we're dealing with potential energy here. We want the kinetic energy here to equal the kinetic energy here so it will cancel out. So we need it to move with a constant velocity. So in addition to the force by the electric field, we will need an external force in the opposite direction with the same magnitude. Now the charge will still move down, but it will not accelerate. So the work done by the external force in this case is negative. Summarizing this case, where we have a positive charge moving down with constant velocity and an acceleration of 0, so we have the net force on it will be 0. The external force will exactly match the electric field force, just in an opposite direction. So as the charge is moving down, the external force is in the up direction, so the work done by the external force is negative. The work done by the electric field, since it's in the same direction as the motion of the charge, is positive. The net force and the net work is 0. That comes right here. A is equal to 0. Net force 0. Net work 0. And here's the key piece. The potential energy of this charge plane system decreases.